Alright, and welcome to the ultimate guide to analyzing quadratics level 3. Now for our very first and only problem, we want to find all key features of the function f of x equals negative 4x squared plus 16x minus 15. And let's always start by finding our zeros, or aka, where do we cross the x-axis at? Well, the first question you want to ask yourself is, let's see, does my a value equal 1? And here I clearly see that my a value is equal to negative 4. So I can't just factor this. Well, when I notice that a is not equal to 1, I ask myself, can every other term be divided by my a value? Well, negative 4 can be divided by negative 4. 16 can be divided by negative 4. But negative 15 cannot be divided by negative 4. So I can't factor out my a term, which brings us to the quadratic formula. When all else fails, label your first coefficient a, label your second coefficient b, and your third coefficient c, and we can use the quadratic formula, which states x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And when we do this, let's go ahead and change all of our letters into parentheses. So we have negative parentheses plus or minus the square root of parentheses squared minus 4 parentheses all over 2 parentheses. And using our colors that we labeled them, let's fill in everything. Our b term was labeled with a green, and so everywhere we see b, we're going to plug in 16. And then switching to orange, which is what I use to label my a term, everywhere I see an a, which is right there and right there, I can go ahead and plug in negative 4 and negative 4. And lastly, for my c term, I can go ahead and plug in negative 15. And from here, what we'll do is we'll go ahead and rewrite our formula way up here, x equals, but let's do this in parts and with different colors. So in this nice little purple, on the outside, we have a negative times a positive, which will give us negative 16, plus or minus, and then we can go ahead and draw our square root. And when I look at the inside, I notice a couple things. Let's use orange for the inside. I see a 16 squared, and you can use your calculator for this, but 16 squared is 256. And here I count up 1, 2, 3 negatives. Well, a negative times a negative will stay negative. And then I say, okay, well, what's 4 times 4 times 15? And let me go ahead and pause the video and use my calculator to figure that out. And 4 times 15 will be 240. And I didn't really quite squeeze that in, so you have my apologies. Now, down on the bottom, let's just go ahead and use green. We have 2 times negative 4, which is, in fact, negative 8. Okay, and so let's rewrite this again. Now we have x equals negative 16 plus or minus the square root of something over negative 8. However, what is actually going on inside my square root? And I look and I see that I have this 256 minus 240. Well, 256 minus 240 is, of course, 16. And from here, we can go ahead and rewrite this one more time. And we'll say this, x is equal to negative 16 plus or minus something all over negative 8. Well, you can either factor this out or use a calculator, but what is the square root of 16? Well, the square root of 16 is 4. And it's from this point we can actually break this up and start to solve it. I would encourage you to pause the video right now, finish taking your notes, and get caught up with me when you can. Okay, so I want to take this, let me back up a second. Alright, I want to take this, and what I want to do is I want to look at that plus or minus, and I want to go ahead and split this up into its two forms. The first thing we see is x equals negative 16 plus 4 all over negative 8. And we also see negative 16 minus 4 all over negative 8. And let's go ahead and start reducing this. I see a negative 16 plus 4 is negative 12 over negative 8. And a negative divided by negative is a positive, and 12 over 8 reduces to 3 over 2, or 1.5. Switch colors here. Here I see negative 16 minus 4, which is negative 20 over negative 8. A negative divided by a negative is a positive, and 20 and 8 can both be divided by 4. So 20 divided by 4 is 5 over, and 8 divided by 4 is 2. And I know that 5 over 2 is actually 2.5. And I have my two x values, or I have my two zeros. So here's what I'm going to do. I'm going to write my zeros over here to the right. X is equal to 1.5 and 2.5. And we're going to leave these here until the very end. Pause the video, finish taking notes, and let's move on to part B. Okay. Let's go ahead and put that back, kind of erase that a little bit. But let's go ahead and find the vertex. So when I look at this, I know that I will typically write it as negative 4x squared plus 16x. And I actually want to create a space right here where I'm going to push that minus 15 over to the side. Why? Because I know that I don't have a perfect constant right there. I also know that I always want my a value to equal 1. So how do I get my a value to equal 1? Well, I simply factor out whatever the a value is. In this case, it's negative 4. So I can write this. I can write f of x equals, and we have our negative 4, which just got factored out. And negative 4 divided by negative 4 gives me 1x squared. And 16 divided by negative 4 gives me negative 4x. And I leave a space and I write my parentheses minus 15. Now, depending on whose class you're in, I gave this a bunch of different names. But let's use our formula b over 2 squared to make our perfect constant. I see that my b term is negative 4. So I write negative 4 over 2 squared. I know that negative 4 divided by 2 is negative 2 squared, and negative 2 squared is, of course, 4. So in here, I can add a positive 4, but I'm not really adding 4. I'm really adding a positive 4 times negative 4, which is a negative 16. And what balances out a negative 16? That would be a positive 16. And from here, I can kind of write my final form, my vertex form. So I write this, f of x equals negative 4, and I want to take my trinomial, which now has a perfect constant, and I want to write it as a perfect square. And so I can kind of write it like this, and I ask myself, well, what number adds with itself to be negative 4 and multiplies with itself to be positive 4? And it's always half of your b term. So half of negative 4 is negative 2. And of course on the outside I have negative 15 plus 16 is plus 1. So from here, I can start to find my vertex. In fact, let's write the word vertex right here. So what do I know? I know that I always set my grouping x minus 2 equal to 0. And to solve for x, of course, I just add 2 to both sides. And it turns out that the x value of my vertex is positive 2. Comma, over here, I have this constant of plus 1, so that must be the y value of my vertex. And now that I have my x values, or my zeros, and I have my vertex, I can graph this and analyze all the key features. Pause the video, finish taking notes, and then when you're ready, let's start. Okay, so what I want to do now is I want to go ahead and graph this, and let me erase this right here. It's hidden from me. Let's go ahead and graph this, and let's always start by graphing our vertex. So my vertex is positive 2, comma 1. So let's see, I go to the right 1, 2, and up 1, and I have that point. Now, I know, switching this nice purple, that my x-intercepts are 1.5 and 2.5. So here is 1.5, and if I go out to 3, here is 2.5. And now I can kind of connect all these things. Okay, and let's just go ahead and start going through our key features. The first thing we want to talk about is our axis of symmetry. And I know that my axis of symmetry is always the x value of my vertex. So I can write x equals 2 because I see a 2. And you can even see it as this vertical line will split through the vertex and split the graph in half. It's going through the line x equals 2. Okay, I know, I'll do this in green, I know that I have a, in this case, a maximum. So I have a maximum at the y value of my vertex at positive 1. We're saying, hey, this thing will never get higher than positive 1. Okay? Now, the last two things I can analyze are my domain and range. So let's talk about domain. And even though I didn't quite draw it this way, this function will never stop going to the right. It will never stop going to the left. So it's essentially going from negative infinity to positive infinity. And so what we would say is that our domain is all real numbers. If I can squeeze that in. And lastly, let's talk about our range. By the way, we know that our domain is all of our x values. Our range is all of our y values. And from here, we write this fancy little bracket, and we say y such that y is, and we always look at our minimum. So since our minimum or our maximum, our y value of the vertex is 1, we know that it's either every value above 1 or every value below 1. And since our graph is going down, we know that it's every value below 1. We say y is less than or equal to 1. And there we have it. We have all of our key features for a level 3 problem. I hope this was helpful, and I'll see you in our next video series.